Okay, example 2. The beam of a lighthouse sweeps across the path of a boat cruising at a speed of 30 kilometers an hour, parallel to the shoreline. Okay, so I'm going to start drawing this as we read. So we have a shoreline, and somewhere on that shore, we have a lighthouse. And then we also know that there is a boat out on the water that is going past the lighthouse parallel along the shore. So I have a boat running parallel to the shoreline. And it says if the boat is 2 kilometers from the shore and stays within the beam of light, at what rate, so we're doing related rates, is the beam revolving when at the instant the boat has sailed 4 kilometers from a point opposite the lighthouse? Okay, so what I know is that the boat is running parallel to the shore 2 kilometers from the shore. Okay, and I've said let x equal the distance the boat has traveled in kilometers. So it says here from a point opposite the lighthouse, it has sailed 4 kilometers. So from this point opposite the lighthouse, the boat is somewhere along that path, and I've called that x, which makes me another right triangle here. Okay, so at the instant that x is equal to 4 is what we're trying to solve the rate of the angle. Okay, so theta is the angle of the beam of light. So I'm going to put theta up here. Okay, so picture, a lighthouse's beam rotates around, and sometimes it'll just do along the shore, right? So it's rotating. And we're just looking at this little piece. So I've made myself another right triangle again, right here. Okay, and so we're looking at trying to find a function for this. So let's see what it is that we know before we write our function. We should write that out. So it's asking us to find d theta dt is equal to what at the instant when the boat x is 4 kilometers from the point opposite the lighthouse. And what I know is that the boat is cruising at a speed, so that would be dx dt, at a speed of 30 kilometers an hour. And that's going to be positive because the distance is increasing. The quantity is increasing as the boat moves past the lighthouse. So that's a positive rate. Okay, so when I am thinking about this, I'm back to my SOHCAHTOA. And again, hopefully you see this as a tan function. Tan theta is equal to opposite, this time is x, over the adjacent, which is 2. Okay? So I have that tan theta is equal to, you might prefer to see that as 1/2 x. This is what I want to take the derivative of. So the derivative of tan, remember we're doing this with respect to time, would be secant squared theta d theta dt is equal to 1/2. The derivative of x would be 1/2 dx dt. Okay, so I am trying to solve for d theta dt. This is my piece that I want to know. And so I must know everything else that I'm trying to figure out. Okay, so I know dx dt, that was the rate of the boat. So that is 30. And I am trying to find d theta dt. So here we are again with this secant theta ratio that I need to know back from my diagram here. And this is where we're going to use this x is equal to 4 piece. So I'm going to redraw my triangle again like I did in the previous question. So I have at the instant when x is equal to 4, The vertical was 2, and here's my theta. So I want to know the hypotenuse because secant theta is h over a, hypotenuse over adjacent. So I need to know my h value. To find that, I'm going to do a quick Pythagoras. 2 squared plus 4 squared, and take the square root of that. So 4 plus 16, I have the square root of 20, which reduces to 2 root 5. So my secant theta ratio will be the hypotenuse, 2 root 5, over the adjacent. The adjacent is 2. Those 2's will cancel, and it leaves me with root 5 that needs to go in as my missing piece, but it also needs to be squared. Okay, so let's see now if we can isolate for d theta dt. Okay, so we have root 5 squared, which is just 5. D theta dt is equal to 1/2 of 30 is 15. And then we would divide both sides by 5. And 15 divided by 5 is 3. And my unit should be, we're working with radians per whatever unit of time, in this case was hours. Okay, awesome. So therefore, what do I know? The beam is revolving at a rate of 3 radians per hour when, you could even say the boat is 4 kilometers away, or when x is equal to 4 kilometers. Excellent. Okay, question number 3. All right, so just to make sure that I have time to get all of these videos in, I'm just going to do one video per example. So I'm going to pause the video here, and I'll see you back for video